Okay, this is ITS128, September 24th, 2024. Let me share my screen. Number 2. Okay, so that's great. Now let me I'm going to log in as me as a student. I have me in here as a student, so it looks more like what you guys see. And all right, so I'm logged in as a student. And this is 128. Okay, so if you recall last time, I didn't get super far. I'm still in the middle of chapter 3. However, let's go see how far I got. I got up to 3.5, it looks like. But if you go to resources and go to Zybook's lab video spreadsheet list. Click on that. Really? All right, let me I gotta fix that. I'm gonna pause it. And so if you click on that link in resources, you get this. Bet you I can do this. Okay, and you get this spreadsheet. And if you look down the spreadsheet, and I have to update it because this is a new semester, and you can still read that. But here we have, this is pretty close. It's the labs. They might be misnumbered. They might be misnumbered, but the labs, and then here's the video on how to do the labs. Right, it starts right where the lab starts. So you recall since let's go to the textbook and see how far I actually got. And so I got up to 3.5, which is this. So what's missing is these 3 challenges, but then list basics and set basics are shown here, are videos here. So for example, if we look at list basics, will this work? Yeah, this should work. Okay, given the user inputs, complete program that does the following tasks. It defines first one defines a list. Okay, so that's great. These wonderful. 3 user inputs. Okay, wonderful. So that's that. And if you go through it, and back then I did a pretty good job of carrying you all the way through. So okay, so I'm gonna remember to show you these where these are. I'll make sure that almost all of them are covered. Maybe not all of them are covered, but almost all of them are covered in a video. And the ones that are not here, I will record this semester, unless it's the one that I choose not to do, because I need to have at least maybe 1 or 2 labs in there where I give you very little help, because I need to gauge how well the class, not you individually, but the class works in sort of their own discovery mode, or they figure out how to do things that are beyond what is covered actually in the lectures. And we do that because we have program learning outcomes and student learning outcomes that we need to measure for ourselves for accreditation, and it's just stuff we have to do so we stay accredited. And so it's part of the quality control of our courses. So anyway, and I only picked like one or two or three or some small number of labs because I don't want, I don't necessarily, okay, so the idea is that you might get an A in the class, but you might, you know, decide later on that you're not a programmer because, the stuff wasn't, easy for you. You had to watch videos very carefully and type in code that I type into the on the video and not understand it really that super well. So those are that there you're getting the experience of programming, and you can go a long way getting the experience of programming, but maybe you yourself don't want that to be your career. But there's lots and lots of jobs around where you have to understand programming, you have to talk to programmers, you have to be able to think about what programmers can do. You might be writing requirements, you understand programming for that reason. So it's all at this level, the undergraduate level, that's kind of what we're trying to do. Master's degree in computer science is a little different. So anyway, so we have those. And then the other thing I want to point out is if you go to this playlist right here, this spring 2023 video playlist by John Johnson, he's another instructor in our program, and I think he's going to be I think we'll be seeing more of John. In fact, John might be teaching this course next semester. I'm not sure, but anyway, he taught this course in spring 2023, and he came in around chapter 4. It was the same kind of thing where I started it out, and then he came in and took over. And he hadn't taught that much when he did this, so he decided he's going to make videos for every single page in the textbook, starting with 4.1. So you'll see that these videos aren't that long, 16 minutes, 9, 7:45, and so on, but they basically cover every single page in the textbook. So they're very good lecture type videos. If you don't understand what's going on, he's very pleasant, and you can tell he wants to help and all that. But I don't think he does any challenges, and I don't think he does any labs. Okay, so that'll be left to me. I can do that, do those. And I want to give you a reason to come and see me. So come and watch my videos. So it's like instead of having a wonderful lecture and a bunch of nice animations and so on, and being real super organized, I'll just sort of help you get the points that you need to do well, or to get a good grade. So those are two things that I wanted to point out. So where are we? Let's go see where we are on the overview. And I think I'm quite sure we're behind. I think we're like maybe a chapter behind. I think I'm gonna so we're in this week here. So we're in chapter 4. So there are those 3 challenges that are left over in chapter 3 that we didn't do. They aren't super important because you'll pick that up as we go along. You're not going to really have to know about binary numbers hardly at all, except for to do some of the exercises, and we'll cover that when we get to it. String formatting. This has to do with how you format strings to print out, that kind of thing. This kind of thing. This is one way of doing it. And, there's a bunch of different ways of doing prints, right? You probably picked up on that. And, this is something that's unique to the language. And most of these most of these input-output things are the statements and so on, our functions are unique to languages. And this one has, these kinds of things, we kind of cover this when we have to use it. And you'll also notice that oftentimes the exercises are not going to be about producing this correctly, and it'll actually give you this string to make sure that your output is formatted so it's easy for the auto grader to grade it. So anyway, I'll cover the. I also am not entirely unconvinced that these sections aren't covered in a previous video. You know, I want to point out that I did videos. I've done videos for lots of these things, for lots of these sections earlier. Um, the the chapters of the book have been rearranged as I go along. So you notice the section numbers are different, and you'll even notice some of the chapters are different. But the content hasn't changed. The content is similar. The Zybooks has a bunch of textbooks like this for different programming languages, and you'll notice if you look at other ones, the exercises are the same except for you're doing it in Java instead of doing it in Python, or you're doing it in C# or C++ and so on. And later on, if you go on and you take the 3-level classes, we do have a programming language series where we actually do learn other languages. The assumption is that you've learned one programming language, and we talk about what's similar in all of them, and there's a whole bunch of stuff that's similar, but then there are these little syntactical things that are different, and that's what's covered. And I use the same Zybook. So for Java, there's a Java one. So you start taking the Java one, you'll recognize, oh yeah, I remember that exercise in 128 or 148, probably more like 148. So all right, so I'd like to start with chapter 4 today. It's so if we go back to here, let's start with chapter 4 and if else branches. So we've just done code where you have one statement after another, and there isn't any thing where, okay, if this value exceeds this value, then we branch off and we do something else. This branching idea in programming we haven't really covered yet. Have we? I don't think we have. Let me just look back here at the right, different types. Okay, last one was types. And so this is the first chapter where we actually can test something if something is equal to 0, or test if something is equal to something else, or we're doing something until something is equal to something, and then after that we branch off and we do something else. Otherwise, we continue to do the same thing, or so on, just different things like that. And of course, in programming languages, a little history. Back when I started programming, and if you ever take an assembly language programming class, where you're writing programs in the commands that the microprocessor uses, when you write programs in Python, then the compiler or translator or interpreter or whatever we call it translates your code, your statements, into a bunch of assembly language programming statements that are like raw to the microprocessor it's different for a different microprocessor, and then that's what actually executes. We do have a course that covers that, but unless you're programming in that language, then you're going to have constructs or statements like this, where you have if, then, else, or if a certain condition is true, you do one thing, otherwise, or else you do something else. And this wasn't always this way. Back in the 50s and 60s and 70s, we didn't have if, then, else. We had if something, go to some line in the program. Otherwise, just continue on with the next line. So that's all we had. And then in the 80s and 90s, when computer science actually became a science, and we had a bunch, the mathematicians got in there and started figuring out all these nice rules that all programming languages should have, so programmers can produce more code without as many mistakes. They came up with basic things like if then else, and then we're going to learn about loops, and there's while loops and for loops, and then after that we start to get into things that are unique to a language. But since the 90s, every language has had this if then else type of construct, and they've also had the same kind of loops that we're going to get into in chapter 5. So this, if you go through these participation activities, you just learn that they have different ways of explaining the branching concept, and you can go through this as if this is a restaurant host, a party of 2 is seated at a certain table. So the host is going through this sort of algorithm in his or her head, and assigns parties to tables based on how many are in the party. Well, anyway, you can look at this. Flow charts. We used to be in our student learning outcomes that you had to have worked with flow charts, and really what happened is back in the 60s and 70s, before we had if then else type constructs, and before we had while loops and for loops, we did have loops, but they were just called do loops. And there was no, and when we wrote code, there was no indentation. Okay, back then, when you wrote a program, it was just all straight inline code. So it was really hard to follow. It was really hard to follow if you had blocks of code, or you did a test, and if the test was true, you did this block of code. Otherwise, you skipped around the block. And with Python, you can't help but indent your code that way, because if you don't indent your code that way, the Python interpreter doesn't understand what you're doing. Python came about because the inventors of Python decided, well, we're going to force programmers to do this indenting thing, and then that'll make it so a lot of new programmers will be able to write code that works. The learning curve will be short. Well, so what I'm getting at is, back before we had indentation, then we had to express our code some way, and so we did it with flowcharts. And so here we have a flowchart, and when you have a diamond-shaped thing, it's usually a test, some sort of conditional test, and the expression for testing if it's true or not is inside the diamond, and then if it's true, it goes out one edge, and if it's false, it goes out another, and then you have other rectangles of code there that are executed based on whatever the condition was. So and so you can see that flowcharts are pretty important for designing programs and so on. But I remember back I'm talking too much about history, but I remember back when I was a young computer scientist, and it was in the late 1970s, and we were all writing Fortran programs, and there was no indentation or anything. We had, if you wanted to branch, you would jump to a particular statement number and handle it that way, and we would end up developing what sometimes was called spaghetti code, because you would have branches and jumps going inside of blocks and then outside of blocks and tests and so on, and it was really hard to follow. And then these scientists or these mathematicians from some place came up, Warner and Orr, those were the last names, and they came up with this way of writing your programs or your algorithms by indenting. and they were called Warner Orr diagrams. And I remember this. And so there were lots of stuff that you couldn't do. You couldn't just jump inside of a block. You had to make every, if you get a block meant there was one entrance and one exit. You have a block of code, and inside the block of code, you can have a bunch of conditions and stuff, but still that was just inside this block. And so everything was a block, and blocks consisted of bigger blocks and so on. Blocks made up blocks. And I remember asking, my fellow colleagues and saying, I wonder if you can actually write code without a go-to statement. If you could write code without having a statement where you have to say, well, okay, I'm at this point in my program, and the next line of code is just not going to work for me. I got to jump over here, and so you just have a go-to statement number 500 or something like that. And then in the later 70s and 80s, and people like Pascal came along, and they showed that you can do anything. And then in the 80s, when then some languages started coming out. I think like Algol was the first one, which is stood for algorithmic language, where there was no go-tos, and it was academic, but then now there's no go-tos at all, and every language, and then of course we'll get to this later on, but then later in the 90s, there became classes, where there started to be classes inside programming languages and objects and so on, and we'll get to that later. But anyway, here we are. We're still learning about these basic constructs, or these basic structures that all programming languages have, and branches is one of them. There's so branch can just be you have a condition that jumps around, where you say if this is true, you do this, otherwise you skip that. So it's if something is true, you do something, otherwise you skip the something. That's just an if. And I say if then, you might hear me say if then. This language doesn't have the word then in it, but lots of other languages, it's if condition and then the word then, and then you do something, and then later on there's an else, and that means that's the other part, where if the if condition was false, then it does the else part. So that's what this one looks like, where you have if the user age is less than 25, you do this thing. If this is false, then you do this thing, okay? You only do one or the other based on if this is true or false. So this is an if, then, else. So there's a then clause, or a then block, and then there's an else block. So that's learning all this, if then else. And so this takes you through that, helps you make sure you understand that. And so there's also and this starts to become unique to languages. There's this else if in this language it's not else if though, right? It's not, it's word something. Oh. Okay, I guess. Oh, no. This is not programming yet. This is not programming. This is like an algorithmic language, because it's not equals, it's a double equal sign is what that symbol. But anyway, so I can do one of these. Okay, so so it's just saying this uses the equality operator instead of this. Good, I'm glad they tell us that. Okay, so let's start. We're supposed to type the program's output. Okay, so first of all, we see number of apples equals 1. And then we have this test here. Is the number of apples less than 3? Yes, it is less than 3. So put a 2. I got to adjust my monitor so I can read this better. Put an A to output. All right, I guess I put an A there. Because it's true. And then put a K. Okay, so then I'm done. I go down here and I put a K. So you see these flow charts are real easy to follow. And did I get it? Oh, wow, awesome. So let's do the last one. Okay. So we start out with number of cards is equal to 11, and then the number, you see, this is good because if you go, once you go through these challenge activities, at the end, sometime or another, if I'm working against an old set of student learning outcomes that I have to evaluate this course on, I don't, not you individually, but in the aggregate, the question is, did they learn about flowcharts? And because of this, and you all will try to get these points, then you will have learned about flowcharts. And it's probably the last time you're ever going to see flowcharts, but at least you sort of understand it. And then maybe someday you can talk about the history about where, oh yeah, we had to learn flowcharts back when I was learning programming. Okay, so first of all, we set the number of cars equal to 11. Then we say, is the number of cars equal to 6? See, that's a double equal sign there. And if it's true, is it true? No, it's not true. So let's go down here. Is the number of cars equal to 20? Is it true? No, it's not true. So we go down here to false, and we got to go around over here. It's kind of a silly thing. Then we come down here, and we just put the K in the output. Right? Is that all it is? Yeah, I guess that's, yeah. Hmm. Let's see what the middle is. Okay, if number of apples is less than 3, so the the fact of the so it's false that the number of apples is less than 3. So it's going to take the false route, and it'll put an F there, and then it'll put a G there. So it'll be FG that goes there. All right, so that's good. Let's go to see what's next. So that's detecting ranges. Okay, so um So you notice in one of those challenge activities, it was saying, okay, so the number of something, and and is it equal to a smaller number? No, it's not. Is it equal to a larger number? No, it's not. So it's false in both cases. Well, what happens if you wanted to know if it's in the range of the first one and the second one? So that's what we're gonna see how we do here. And they use this, it's called an if else structure. And that's just what they call it in Python, but you get the idea. There's a bunch of else ifs inside here. So let's say you want to find out what team your child is, or your whatever is uh they your child wants to play soccer and goes to the soccer club, and what team is your child going to play on? Well, so it's going to look at ranges. It's going to look at less than 6, then it's going to look at between 6 and 8, and then it's going to look between 8 and 10, and it's going to look between 10 and 12, and then it's going to look after 12. See, so that's what these conditions are. So okay, so if it's less than 6, you say sorry. So if today's the 6th birthday, then it's going to be, at least it passes this one. Okay, it's going to be true. No, it's going to be false. So it's going to not do this one. It's going to go down here. And so the next question is the age less than 8? Wait, what happened to oh yeah, if the age is less than 8, then okay, so if it's his 6th birthday, then it's true that the age is less than 8. It's not true that it's less than 6, so this is not the case. But it is true that it is less than 8, so then this is the case. So if your child is 6th birthday, it's going to be U8 all the way up to just the day before your child's 8th birthday. Okay, if it's 7, if your child's going to turn 8 tomorrow, you just missed the cutoff, and you're going to play on U8 team. If you would have waited one more day, or if the cutoff were a day earlier, then this would have been false because you would have been equal to 8. And then you would be down, you would hit, this would be this would become what is true. So then you'd be on U10. So where you can have errors using this kind of thing is when you're close to the edge. It's like when you're 8 years old, on your 8th birthday, you're in the next level. Whereas if this is, for example, less than or equal to 8, then you would still be in the previous category and so on. So here's a dragging thing. Indicate the range corresponding to each branch. X is a non-negative integer. So if X is less than 10, when are we supposed to do this? Oh, I guess so. Less than 20. This is too easy. So anyway. See, this is all real simple stuff. All right. 2 of these. Okay, I'll do one of these. Okay, it's start. I'm going to do the last one. Okay. Indicate the range covered by the following decision. Assume X is a non-negative integer. Okay, so the range here is okay, so if it's less than, okay. Okay, so if it's less than 29, okay, it cannot be below 19. So if it's between 19 and 29, if it's in between 19 and 28, well, I'm going to say 28. I'm not sure that's exactly the right answer because you can be over 28 but not yet 29. But I think we're just dealing with integers here. So you see that right here, right in this range here, it is covered by 19 covered by ages. Well, it's an integer, so it's not ages, it's just an integer. See, 18 is not covered in here because 18 would be covered up here where it's no, wait, let's get this right. I have to get this right. So if it's less than 19, it does this. Let's see. So if it's less than 19, let's see. I think my thinking is wrong, but all right. I'm gonna check it and see if I got this right. I did get it right. Okay. I was somehow thinking that it was up here. Anyway, okay, so you can see that if it's 18, it's going to be covered in this range right here. It's not until it becomes equal to 19. If X is equal to 19, it's not going to be in this range here. It's going to skip down to here. And here is where it's going to be. As long as it's between 19 and 28, it's going to be down here. But once it hits 28, then this is going to be false, and it's going to go down to the else case. All right, so that works. That's this. Using multi-branch ifs to detect. Okay, so here's how we use, what's the difference between this and this? I think it's the same. I think this is, we're just seeing what it looks like with flowcharts now. So let's, if it's less than 10, you go here. If it's less than 20, you go here. Okay, so let's do one of these. Okay, start. Type the range for the given branch, assuming X is a non-negative integer. Okay, so the range for Y equals 1 is going to be between non-negative integer. So between 0, if it's between 0 and if it's between 0 and 10, if it's between 0 and 10, then it's going to be y equals 1. Then y is going to equal 1. Wait, what? Oh, yeah, range for y equals 1 is when x is between 0 and 10. Because if x is equal to 11, then it's going to go down to this one. And it's going to be then it's going to be y equals 2. So let's see if this is right. And it is. Okay, let's do the last one. Okay, type the range for the given branch. Assume x is a non-negative integer for range y equals 4. That's this one. So it's going to be 25. If it's less than 25, it's going to be y equals 3. So if it's 25 or greater, it'll be y equals 4. So that's what that is. So this should be the answer. Okay, so that's another thing that we do with if else. This is detecting. Oh, did I not do? Did I not do this one? Yeah, no wonder, no wonder. Yeah, okay, so double equal means equal, exclamation point equal means not equal. See, so it's instead of the word equals, you use use a double equal sign. So if x is equal to 3, kind of thing. So let's do a quick participation. Okay, so the number of puppies is equal to 4. If the number of puppies is equal to 4, print 8. Otherwise, print E. Well, gee, that's kind of 8. Print 8 is A, and then print E. Then I'm going to print G because after we're done with this, then we skip out of the if else block or if else statement, then we go to this one here. So then that's going to be a G, right? So that's pretty easy. Let's do the next one. Write an if else statement for the following. Let's do it. Let's do the next one. Let's do the harder one. Write an if else statement for the following. If the number of difference is not equal to minus 16, then do this. Otherwise, do that. Okay, so if num difference is not equal to minus 16, colon, and this is the then clause, but they don't use the word then in Python, so neither do we. Just work. If it's equal to 16, not equal to 16, then we're going to do total difference is less, subtract 10 from total difference. Okay. Otherwise, total difference equals num difference. And that's it. So first we read num difference. And is num difference less than, no. Is num difference not equal to minus 16? If it is, then set total difference equal to that. If this is not true, if it's you do the else case, which is this one, And that's what this is. So let's see if this is right. Oh, uh-oh. Did I spell something wrong? I spelled something wrong. Wait, what did I do wrong? Total difference. Oh, what? Wait. Nine five. Doesn't like that. Oh, wait a minute. I have to define total difference, don't I? Oh, never mind. Does anybody see what I did wrong? I was thinking I take total difference, subtract 10 from it. No, I set total difference equal to minus 10. I set total difference equal to minus 10. Minus. What's going on? Minus isn't working. Oh, that's because I have to try again. That's why it's not letting me fix it. Okay, do I get to try again? I just fix it. Is that what I do? So minus. All right. Minus 16, minus 10. Otherwise that. Okay. All right. So that's that. Okay, so in in Python, okay, so now they finally tell you this. In Python, we don't use this, we don't spell it out else space if. We condense it into a word elif. Elif. And Python's the only language I know that uses elif. Some languages put no space between the else and the if, and other languages just let you put a space between the else and the if. But anyway, so this is how that looks like. So if you have a bunch of if else if else if else if else, you can do it this way. You can use that elif like this. So let's do this one. If side number is 8, output octagon. Otherwise, output not an octagon. If side number equals 8 colon print octagon. I'll use a single octagon. Octagon. Otherwise, print not an octagon. Mixing my quotes, that's okay. All right, let's do the last one. Oh, okay. So if it's this, then do this, then do that. Otherwise, you don't put another kind of otherwise you put another kind of polygon. So you say if side count equals 4, then we print square. Elif side count equals 5. Then we're going to print pentagon. Elif side, I spelled side count incorrectly here. Side count equals 8. then output octagon. Otherwise, print another kind of polygon. Okay. Oh, hmm. What did I get wrong? Oh, it doesn't like periods, does it? Doesn't like periods? Well, that's the way you're gonna be. So what do I do now? Can I just fix it? I can just fix it. Well, that was kind of it. Okay, so what's the next? What's this one? Write an expression so that user is 18 is printed if the value of user age is equal to 18. Write only the expression. If let's this is a challenge. Okay, um if user age equals 18. All right, well, these are just kind of easy. Okay, so we did 4.2, we did 4.3. Let's do detecting ranges. Then we do detecting ranges with branches. Okay, so here we're going to learn about these relational operators, and yeah, so we can do ranges, and so we learn that this means if A is greater than B, this means A is less than B. You know, A is on the left, B is on the right, and then this is less than or equal to, and this is greater than or equal to. So those are the four kinds. And so num dogs is greater than 10. Num dogs is greater than or equal to 5, greater than or equal to 5. Okay. So if first you enter in the age, if it's less than 16, you say too young. If it's less than 25, so this means if it gets to here, that means it's 16 or greater. Okay, even though we're only testing if it's less than 25, we know it's not going to be less than 16, because if it was less than 16, it would have been, you know, it would have been up here. Okay. So if the user age is less than 25, that means it's going to execute this. If it's between, if it's 16, if it's between 16 and 24, it's going to execute this. And then here, if user age is less than 40, well, it's actually, if user age is between 26 and 40, because if it's 25 and 40, because if it's less than 25, it's going to be here. Okay, if it's less than 16, it's going to be here. So that's the idea here. So when you're doing these LIFs for detecting ranges, you only have to detect like the bottom ranges as you go down the line, because, well, I guess you only detect the top of the ranges as you go down the line, because um because the ones that are less than the previous ones are caught in the previous block. Anyway, you know what I mean. I wasn't explaining it very well. So let's see what kind of challenges we have. So you can do these, figure out how they're expressing it. Okay, let's do this one. We read in X, it's going to be 10, the value 10. If it's less than 5, we print N, otherwise we print D. And then when we're all done, we print G. So it's going to be D, G. Oh, okay. What did I do wrong? Well, it's greater than 5. I said less than 5. So it's going to give me another chance. Now it's less than 5. So it's going to print. Input is 3. If it's less than 5, it's going to print T. Then it's going to print M. Is this right? Yeah. Okay. Let's do number 4. Okay, so we're going to read in X. It's going to be an integer, so the value's 5. If it's less than or equal to 5, print E. Well, that's what it is. And then we skip out of the whole if elif block, and we don't print anything else. Looks like we don't print anything else, don't we? Yeah, okay. So last one. Okay, here it's 25, so we're going to end up printing N. We're going to print N because it's going to get caught with this one. It's going to not get caught with this one. It's going to not get caught with this one. It will get caught with this one. So then it does that print. So that's what that is. All right, what's this one? Variable user grade. The variable user grade is read from input. Use operator chaining to complete the if-else expressions. Operator chaining. Well, if the value of user grade is between 9 and 12, if user grade, I'm sorry, is greater than or equal to 9 and user grade is less than or equal to 12, then print in high school. Is that what they're asking for? Chaining. Well, I'm quite sure that's the answer. Let's see. What did I do wrong? Oh. Wrong language. Should be and, the word and. There we go. In every other language, it's ampersand, ampersand, except for Python. Okay, what's the next one? Basic if-else expressions. Complete the if-else statement to output less than 20 if the value is less than 20. Otherwise, output 20 or more. So, okay, so great. So it's going to be this is just too easy. It's just this one would be well, you can do that. All right. Working with ranges. When the input variable is that, otherwise, if it's in between that, do that. Otherwise, if it's greater than 25, do that. Okay, so we're going to say if drink size is less than or equal to 7, then output too small. Otherwise, if drink size is greater than or greater than 7, and less than, and drink size is less than or equal to 25, it's inclusive. Then if that's the case, then output acceptable. Otherwise, print. All right, otherwise it's going to be greater than 25 because it's nothing else it can be. So I'm not going to bother to test if it's greater than 25. I'm just going to print too big. And okay, excellent. Let's just take a look at the next one. Oh, okay, I did that one. This one is, did I do that? Oh, geez, I didn't do this one. That's weird. Skip these things. Okay, let's see what this one is. Let's do number 3. Okay, the number of integer that is read from input. If it's less than or equal to 9, output not enough chairs. Otherwise, a good number of chairs. So it's going to be if number of chairs is less than or equal to 9, then print not enough chairs without the period. Otherwise, print a good number of chairs, no period. Okay, these are just kind of really, what's this? Okay, here we're, if task count is less than 24, then add 3 to required groups. Otherwise, subtract 5 from rejected groups. Well, if task count is less than 24, then required groups get 3 added to it. Otherwise, rejected groups get 5 subtracted from it, I think. He thinks. Well, that's quite a deal there. Okay. So what's the next one? Working with ranges. I did that one. So I was going to see what. Okay. So when the input variable number of items is greater than 16, it got to do that. If it's between 7 and 16, it does that. If it's between 0 and 6, if it's less than 0, it's that. Oh, shoots. So this is kind of a more complicated one, so I guess I can do it. If number of items is greater than 16. And then I'm going to do LF greater than 16, 7, 16, 0, 7. Else. So this is greater than 16. This is 7 and 16 inclusive. Oops. 16. Should be 7. And then the next one should be between 0 and 6. So, the tricky part is getting the inclusive and exclusive right. Okay, so the first one is greater than 16. The second, I'm printing something, aren't I? And so the first one is going to be next one is mid-sized box. Small box. And invalid. All right, so I think this is probably pretty close to what should be. So when you test these things, I got it wrong, didn't I? Oh no, I get it. Oh no, I got it wrong. Oh, I spelled invalid and put wrong. Okay, it wanted a capital I instead of a lowercase I. So you can fix that. But when you're testing these things, you want to test the boundary condition. So you want to test, just so you'll test, you'll test 17, and then you'll test 16, and then you'll test, 8 and 7, or you'll test 15, and then you'll test 8, 7, and 6, and then you'll test, 5, and then you'll test, 0, 1, 0 and 1, and a minus 1. And so you test the numbers around these these boundaries here, just to make sure that they're all correct. And that's a good, so if you may have to come up with a test plan sometime if you write your code, or if you're writing your code with a team of people, and they they'll want you to, you'll have what's called a code review, and y'all get in a room, and everybody looks at everybody else's code. You go down the line, and you explain your code and so on. And so those are the kinds, and then so they're going to ask you, so what do you do to test it? And then you explain, I use these test conditions. So anyway, so that's something you want to learn, or you want to think about. Okay, what's next? Well, here we're detecting ranges with gaps. Multiple features, gaps. So this is pretty similar. You just have to put the conditions on both sides. Here, if it's less than or equal to 12, it's one thing. If it's greater than or equal to 65, it's another thing. Otherwise, if it's in between, it's it's a third thing. So So that's another type of quite common range test that you may have to write sometime. You can also do it this way, where you put the both conditions, the upper and the lower bound, and then you may have some invalid ones that don't fall in either category. So we can do oh, it's 3:06 already. All right, so I guess this is as far as we can go today. I'll try to make up for this. See what's behind me. I guess I'm walking along the beach. Are there any questions? Anybody have any questions? All righty. Well, thank you, and I'll see you next time. Thanks for watching.